Okay, which statement is not true? I didn't realize that many of these ended up in this lecture. That's okay, though. So which statement is not true regarding the scalability of SaaS apps? Shared nothing clusters scale better, generally speaking, than systems built from mainframes. Relational databases scale better than so-called NoSQL databases. The programming language used isn't a main factor in scalability. And scalability can be impeded by any part of the app that becomes the bottleneck. So one of these statements is not true, other things being equal. Not true. Initial vote says, I think, yeah, different people's smartphones have different shades of green, but I think it's, you're holding up a thing that's got 4 colors. You're not allowed to do that. Okay, that's better. Okay, green is indeed correct. This was not the world's most challenging question, but it's really an excuse to bust a couple of myths around the other ones. So given that we just talked about one reason that you might use a NoSQL database is that you run into scalability problems, that should make it pretty obvious why green is the non-true statement among these choices. But looking at the others, shared nothing clusters scale better than systems built from mainframes. The first search engine that beat out AltaVista by having a larger vocabulary was built in this exact way. And it's not uncommon for Chile's large SaaS sites to employ hundreds of servers in a cloud computing cluster, the aggregate capacity of which dwarfs the largest mainframes that ever have been built. In fact, there was an interesting comparison about how much Amazon EC2 capacity it would take to equal the computational capacity of Watson. And as Dave Patterson pointed out in an early lecture, you could rent the equivalent of Watson's computational capacity for less per hour than many attorneys and accountants charge. So it is absolutely true that shared nothing clusters do scale better. The trick is that you have to architect your software so that it runs well on a shared nothing cluster. And the kind of app architecture that we've been looking at is largely geared toward, we have these great scalable clusters. What choices can we make so that our apps will be able to be deployed on them? What about the programming language used isn't a main factor in scalability? This statement is true and I think doesn't get the recognition that it sometimes deserves. For a long time, people obsessed over the performance of languages. Oh, you're using an interpreted language? What a wimp. If you compiled it, it would be a lot faster. Computers are what, 1,000,000 times faster now than when the C language was invented? Moore's law has blessed us. Let us not squander the blessing. If you can scale your application out by adding more computers in a cloud computing setting, then the performance you're getting out of each computer is not really that critical as long as it's good enough. So people obsess about performance way too much. And as John Osterhout and others have pointed out, the best performance improvement is the one that goes from the non-working state to the working state of an application. And the reason we've invented modern languages, even though they have a performance cost, is that they allow you to focus more on the what as opposed to focusing on the gory details of the how. So the programming language used really is not a factor in scalability. And if the other person is using a better language and gets their app running faster than you do, and they beat you to customers, then so much for performance, right? And lastly, scalability can be impeded by any part of the app that becomes a bottleneck. Again, clearly a true statement on its face, but it doesn't get the actual attention it deserves. When the app is running too slow, people immediately start scrambling for things like, let's change the language we're using, let's get faster servers, let's add more memory. A thing you could actually do is measure the app. You could measure and find out what part of the app is slowing things down. And when we talk much later about operations and how to deal with DevOps, there are tools that will allow you to run the app and say, oh, the only reason my app is slow is these 5 lines of code are really idiotic and they're written backwards. And if I just change these 5 lines, the problem goes away. So scalability, there's many ways that an app could fail to scale. And when it's not performing the way you want or not scaling the way you want, the first thing you need to do is understand what's going on that is breaking. It could be anywhere, right? People think, oh, the database doesn't scale, my app is too slow, therefore the problem must be that I'm running into the database limitations. Probably not true. We're going to talk about Pivotal Tracker later on, which is a tool for letting you keep stories about your app on the web and stuff. All of Pivotal Tracker for the whole world runs on a single server with a single database. So most people who say the database is the problem just haven't been in business long enough. Look for the scalability bottleneck, and sometimes it's much easier to resolve. So we're done on that question.